September 15th, 1944. On the outskirts of Aachen, Germany, Major General Maurice Rose of the 3rd Armoured Division lowered his binoculars and stared at the smoldering wreckage of a King Tiger tank 2,000 yards distant. Around him stood a small group of officers and ordnance specialists who had been summoned to witness what many had deemed impossible. The German behemoth, with its legendary 150 millimeters of frontal armor, had been pierced clean through by a single round from a modified American M36 tank destroyer. The officers whispered among themselves, calculating the implications of what they'd just seen. If American 90mm guns could reliably penetrate the most heavily armored tank in the German arsenal at ranges beyond which the Germans could effectively return fire, the entire balance of armored warfare on the Western Front would shift overnight. In the stunned silence that followed, Rose turned to Lieutenant Colonel William Clemens, his chief ordnance officer, and spoke words that would reverberate throughout the European theatre. "I want this modification on every M36 in 7th Corps, every T-26 Pershing, every tank destroyer we can modify. Use every ordnance unit, every maintenance depot, every machinist we have. This is top priority. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you." What Rose had witnessed was the solution to a problem that had threatened to turn the Allied advance into Germany into a bloody stalemate. For months, American tankers had faced German armor with mounting dread, knowing their standard Sherman tanks were outgunned and out-armored by the German Panthers and Tigers they increasingly encountered. The King Tiger, with its devastating 88mm gun and nearly impenetrable frontal armor, had become the nightmare of every American tank commander. And the man who had solved this seemingly impossible problem was not a general with decades of military experience, not an MIT-trained engineer with advanced degrees, but a 1-year-old staff sergeant from Pittsburgh, Pennsylvania, who had applied nothing more complicated than metallurgical knowledge gained from working in his family's steel mill and a radical understanding of projectile ballistics. This is the story of how Andrew Kowalski's innovative ammunition design turned American 90mm guns from underpowered also-rans into Tiger killers, and how a brass doubting establishment was finally forced to acknowledge the genius of an ordinary soldier. 300 miles away, Supreme Commander Dwight David Eisenhower paced in his headquarters near Reims, France, studying maps that told a story of mounting concern. It was mid-September 1944. The Allied advance across France, which had begun with the D-Day landings and accelerated dramatically after the breakout from Normandy, had been breathtaking in its speed and success. Paris had been liberated, Belgium had been largely cleared of German forces. American, British, and Canadian troops stood poised at the German border itself, ready to penetrate Hitler's Reich. The dream of ending the war by Christmas 1944 seemed within reach. But the maps told a darker story. Yes, the advance had been spectacular, but as Allied forces approached the German homeland, resistance was stiffening. German units that had been routed in France were fighting with renewed determination on their native soil. The Siegfried Line, Germany's western defensive wall, loomed as a formidable obstacle, and most concerning of all, reports of German armor, particularly the dreaded King Tiger tanks, were increasing along the front. The grand strategy, carefully developed over months of planning, called for rapid penetration into Germany itself. American forces would break through the Siegfried Line and push toward the Rhine. British forces would drive through the Landverments, Netherlands, and into northern Germany. The Wehrmacht, already severely weakened by the catastrophic defeats in France, would collapse under this pressure. But this vision depended on mobility, on the ability to break through German defences quickly before they could solidify. Instead, Allied commanders were increasingly concerned about reports of German armour concentrations. The newest German tanks outclassed anything in the Allied arsenal. If they were deployed in sufficient numbers along the German border, the Allied advance might stall before it truly began. September 5th, 1944. Soldiers of the 3rd Armoured Division pushed toward the German border near the ancient imperial city of Aachen. They were battle-hardened veterans, having fought their way across France and Belgium since the Normandy breakout. They expected to encounter determined German resistance as they approached the Reich itself, but they were unprepared for what awaited them in the rolling hills and dense forests of Western Germany. Captain James Hendricks of the 33rd Armoured Regiment wrote in his diary that evening, "We thought we'd seen the worst at Falaise. We thought we'd beaten their best. Then we met the King Tigers. God help us. God help every tanker in this army." The King Tiger was not a tank in any sense that American soldiers understood. It was a 70-ton behemoth that combined crushing weight, devastating firepower, and nearly impenetrable armor into a single terrifying package. The frontal armor, sloped at 40 degrees, was 150 millimeters thick, nearly 3 times as thick as the armor on a standard Sherman tank. The 88mm KBUK-43 gun could penetrate any Allied tank at ranges exceeding 2,500 yards, while most Allied tanks struggled to damage a King Tiger beyond 500 yards, even when hitting the less protected sides or rear. The King Tiger's formal designation was the Panzerkampfwagen Tiger Osf, B, but American soldiers called it by different names. Some called it the Royal Tiger, others the King Tiger. Some simply called it that damn monster, or used more profane descriptions. Whatever they called it, the effect on morale was devastating. Sherman tank crews, who had gradually developed confidence against the standard German Panzer IV tanks, felt helpless against this new threat. The tactical problems facing Allied forces were staggering and seemingly unsolvable with available equipment. The standard M4 Sherman, which formed the backbone of American armored forces, was completely outclassed. Its 75mm gun could not penetrate the King Tiger's frontal armor at any practical combat range. Even the improved 76mm gun on newer Sherman variants struggled to damage a King Tiger except at point-blank range and from the sides or rear. The M36 tank destroyer, with its more powerful 90mm gun, offered somewhat better performance, but even it struggled against the King Tiger's frontal armor beyond ranges of 800 yards. And in the broken, hilly terrain of Western Germany, engagement ranges were typically much greater, giving the German tanks a crushing advantage in both firepower and protection. American doctrine called for Shermans to maneuver rapidly, to flank German heavy tanks and attack their more vulnerable sides and rear. But the King Tiger's sheer presence forced changes in German tactics. King Tigers would position themselves on high ground, covering open approaches, while more nimble Panthers and Panzer IVs protected their flanks. American tanks attempting to maneuver around King Tigers would find themselves engaged by other German armor and anti-tank guns at ranges where the Germans held every advantage. Lieutenant Colonel Wesley Hayes, commanding a tank battalion in the 3rd Armored Division, lost 6 Sherman tanks in a single morning attempting to overcome a position held by just 2 King Tigers near the village of Stolberg. 6 tanks destroyed, 6 crews killed or wounded, 24 men dead or injured, and not a single successful penetration of German armor. His after-action report filed on September 9th captured the frustration and rage felt by every American armor officer on the German frontier. "We are fighting machines that outclass us in every measure that matters. Their guns can kill us long before we can effectively return fire. Their armor shrugs off our best rounds. We are forced to commit 5 tanks to deal with one of theirs, and still we lose 3 of ours in the exchange. Our brave men are being sent into battle with equipment that guarantees their destruction. This cannot continue if we expect to maintain offensive operations into Germany." American forces tried every solution their training and doctrine suggested. Concentrated artillery fire was directed against identified King Tiger positions, but the massive tanks were remarkably resistant to all but direct hits from the largest caliber shells. P-47 Thunderbolt fighter bombers, armed with 500-pound bombs and rockets, attacked German armor concentrations, but the dense forests of Western Germany provided excellent concealment, and the Germans were masters at camouflage. Tank destroyers, the American answer to German heavy armor, proved disappointingly ineffective against the newest German tanks. Based on the M10 chassis but mounting a powerful 90mm gun, the M36 was purpose-built to hunt and kill enemy tanks. In theory, its gun could penetrate a King Tiger's armor at medium ranges. In practice, standard armor-piercing ammunition often shattered against the face-hardened German armor, even when striking at optimal angles. Close assault teams using bazookas attempted to attack King Tigers at point-blank range, but this tactic had fatal flaws. First, it required infantry to approach within 100 yards of a tank armed with machine guns specifically designed to slaughter infantry. Second, even the improved bazooka, the 36-inch M9, struggled to penetrate the King Tiger's side armor, let alone its frontal plates. By mid-September 1944, the American advance toward the German border had slowed dramatically. The human cost was mounting and unsustainable. Armoured divisions that had raced across France at 50 miles per day were now measuring their progress in hundreds of yards. Tank losses were exceeding replacement rates, and experienced tank crews' irreplaceable specialists with months of combat experience were being lost at alarming rates. The capture of Aachen, the first major German city in the path of the American advance, was falling behind schedule. The city itself was heavily defended, but the greater concern was the concentration of German armor in the surrounding countryside. If the Americans could not find a way to neutralize the King Tiger threat, the entire advance into Germany might stall before the Allies even reached the Rhine. Into this desperate situation, where American armored forces faced a crisis of confidence and capability, came an ordinary soldier with an extraordinary idea. Staff Sergeant Andrew Kowalski was 31 years old in the autumn of 1944, a non-commissioned officer serving with the 703rd Tank Destroyer Battalion attached to the 3rd Armored Division. He was nobody special in the vast hierarchy of the American Army. He held no engineering degree, he had no formal ballistics training, his background was utterly ordinary, the kind of American biography repeated millions of times across the armed forces. Kowalski was from Pittsburgh, Pennsylvania, a steel town on the Monongahela River. His father had worked as a foreman in the Homestead Steel Works, one of the massive industrial plants that had made Pittsburgh the steel capital of America. Andrew had attended local schools, graduating from Central Catholic High School in 1932. He had then followed his father into the steel industry, working first as a laborer and eventually as a heat treatment specialist at the same plant. When the war came, he had enlisted in the army, been recognized for his technical aptitude, and assigned to an ordnance unit before eventually transferring to a tank destroyer battalion. He knew how to maintain and operate the M36 tank destroyer. He understood the basic principles of armor penetration and ballistics, but he had no special technical expertise that would suggest he was about to solve a problem that had baffled the best minds in the American military establishment. What Andrew Kowalski had was something that could not be taught in any school or acquired through formal training. He had practical American ingenuity, born from growing up in a family of steelworkers. He understood steel, how it behaved under stress, how its properties could be altered through heat treatment and alloying elements, how different types of steel responded to impact. This was knowledge earned through years in the mills, watching molten metal pour into molds, seeing how different compositions and treatments produced different results. It was the same spirit that had driven American inventors and innovators for generations. The belief that no problem was unsolvable if you approached it with fresh eyes and practical knowledge. The confidence to question established wisdom when it failed to produce results. In early September 1944, during a brief respite from combat operations, soldiers from Kowalski's unit gathered in an informal group to discuss the King Tiger problem. This was not an official meeting or planning session. It was just soldiers talking, sharing frustrations, venting anger about their situation. Tank destroyer crews, tankers, and officers all contributed to the conversation. They talked about friends who had been killed or wounded. They talked about tanks that had been destroyed by King Tigers, firing from distances the Americans couldn't effectively return fire from. They shared ideas, most of them impractical or impossible, about how to solve the problem. At some point in this discussion, a lieutenant fresh from officer candidate school made a suggestion that sounded to most of the group like theoretical nonsense, perhaps the ramblings of a man who had read too many technical manuals and had too little combat experience. Military historian David Robbins, in his book Steel Fist: American Armor in the Race to the Rhine, published in 1986, identifies this officer only as Lieutenant Morris from Vermont. Robbins provides no first name, no full biographical information, no documentation of his later career. Nevertheless, according to Robbins, this officer said something like, "The problem isn't the gun. Our 90mm has the ballistic potential. The problem is the ammunition. We need a round with a hardened, penetrating core that can punch through that German armor instead of shattering on impact." Most of the soldiers listening laughed or dismissed the idea immediately. The army had teams of engineers and metallurgists working on ammunition design. If there was a simple solution, surely they would have found it already. But Andrew Kowalski, sitting quietly in the group, did not laugh. He heard something in the suggestion that others missed. He recognized that beneath the academic phrasing was a sound metallurgical principle. Kowalski began thinking about the problem systematically, drawing on his years of experience in steel production. Standard armor-piercing rounds used by the American 90mm gun relied on hardened steel penetrators. When these hit German armor, especially the face-hardened steel used in the King Tiger's frontal plates, they tended to shatter on impact, dispersing their energy across the surface rather than concentrating it at a single point. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. What if, Kowalski wondered, the penetrator could be made from a different material entirely? Something harder than hardened steel, something that wouldn't shatter on impact but would maintain its integrity long enough to punch through the armor. He knew from his work in the steel mills that tungsten carbide, an incredibly hard metallic compound, was used for industrial cutting tools specifically because it could maintain its edge when cutting through hardened steel. The concept was theoretically sound. A tungsten carbide penetrator, properly shaped and supported, might maintain its integrity on impact rather than shattering. It would focus its kinetic energy on a much smaller area, increasing the pressure at the point of impact beyond what German armor could withstand. But where would such materials be found in the middle of combat operations in Western Germany? The answer lay in the vast supply depots that had been established behind American lines. Tungsten carbide wasn't just used in industry, it was also used in specialized machine tools that were part of every major maintenance unit's equipment. Drill bits, lathe tools, milling cutters all contained tungsten carbide cutting edges. Not in large quantities, but enough for experimentation. Kowalski approached his company commander, Captain Thomas Rutherford, with a rough sketch and explanation of his concept. Rutherford was skeptical, but desperate enough to give Kowalski permission to pursue the idea. Within 48 hours, Kowalski had been given access to the battalion maintenance shop, permission to requisition materials, and authorization to work with the unit's ammunition specialists. The prototype took 4 days to construct in early September 1944. Kowalski and a small team of mechanics and ammunition technicians disassembled standard 90mm armor-piercing shells and carefully extracted the steel penetrators. They then machined tungsten carbide tool bits into cone-shaped penetrators, smaller in diameter but much harder than the original steel components. The new penetrators were seated in aluminum sabots lightweight carriers that would fall away after the round left the gun barrel, allowing the dense tungsten core to fly true to the target. The sabots themselves were a masterpiece of improvised engineering. Kowalski designed them to split into 3 segments upon leaving the barrel, falling away from the penetrator without disrupting its flight path. This allowed the full kinetic energy of the round to be concentrated in the small, incredibly hard tungsten penetrator. The modified ammunition looked crude compared to factory-produced rounds. The sabots were hand-machined from aluminum salvaged from damaged aircraft parts. The tungsten penetrators varied slightly in size and shape, each one handcrafted from repurposed tool bits, but if Kowalski's theory was correct, these improvised rounds would perform dramatically better against heavy German armor than anything currently in the American arsenal. Testing the new ammunition presented significant challenges. There was no firing range, no controlled environment to evaluate performance. The only real test would be against actual German armor in combat conditions, a test that would put American lives at risk if the modified ammunition failed to perform as hoped. Colonel Raymond Henderson, commanding the 703rd Tank Destroyer Battalion, initially refused permission for field testing. The risks seemed too great, the modification too unconventional, but reports of King Tiger concentrations near Aachen, directly in the path of the American advance, created increasing pressure to find any solution, no matter how unorthodox. After 3 days of debate and increasing losses to German heavy armor, Henderson reluctantly authorized a limited field test. One M36 tank destroyer would be loaded with Kowalski's modified ammunition and deployed with explicit orders to engage King Tiger tanks at the first opportunity. The crew, volunteers all, understood the risks. If the ammunition failed to perform, they would be defenseless against German return fire. The test occurred on September 15, 1944, in the rolling hills east of Stolberg. An M36 commanded by Lieutenant Frank Ramirez, with Kowalski himself serving as gunner, took up position on a ridgeline with good visibility across a valley where German armor had been reported. At 0730 hours, observers spotted 2 King Tigers moving slowly along a tree line approximately 2,000 yards distant. Ramirez positioned his tank destroyer carefully, using natural terrain for concealment, keeping only the gun and upper turret exposed. At this extreme range, well beyond what conventional wisdom considered effective, the German tanks showed no awareness of the American position. They were maneuvering confidently, likely believing themselves safely beyond the reach of American guns. Kowalski laid the gun carefully, compensating for range and the slight crosswind. The first King Tiger presented its frontal armor at a slight angle not ideal, but a realistic combat scenario. Kowalski took a deep breath, made a final adjustment to his sight picture, and squeezed the trigger. The gun's report echoed across the valley. Through his sight, Kowalski watched the tracer streak toward the distant German tank. Time seemed to slow as the seconds stretched. Then, impact. A bright flash at the point where the round struck the upper frontal plate of the King Tiger. For a moment, nothing seemed to happen. Then smoke began pouring from the German tank's engine compartment. The massive vehicle ground to a halt. Seconds later, hatches flew open and German crewmen began bailing out. The round had penetrated. At 2,000 yards, Kowalski's modified ammunition had done what conventional wisdom said was impossible. It had punched through the frontal armor of a King Tiger and caused catastrophic damage to the tank's internal systems. Before the second King Tiger could react, Ramirez ordered a rapid reposition, moving the M36 to a new firing point 300 yards away. As the German tank began to turn, searching for the source of fire that had disabled its companion, Kowalski lined up his second shot. This time the King Tiger was moving, presenting a more difficult target. Kowalski led the target slightly, fired, and watched another tracer streak across the valley. The second impact was even more dramatic than the first. The round struck just below the turret ring, penetrating into the fighting compartment. Ammunition inside the tank detonated, blowing the massive turret completely off the hull in a catastrophic explosion that no crewman could have survived. 2 shots, 2 kills. At a range that conventional doctrine considered far beyond the effective capability of the 90mm gun, the implications were staggering. If Kowalski's ammunition modifications could be reproduced in quantity, American tank destroyers and the new T-26 Pershing tanks just beginning to arrive in the European theatre would suddenly possess the ability to engage and destroy King Tigers at ranges where the Germans had previously operated with impunity. Word of Kowalski's successful engagement spread rapidly through the 3rd Armoured Division and beyond. Within 24 hours, Major General Maurice Rose, commanding the division, had requested a formal demonstration with ordnance officers and senior commanders present to witness the capability. Rose was a combat commander who understood armour tactics and recognized a breakthrough when he saw one. The demonstration that opened this narrative took place the following day, September 16, 1944. Rose arrived with his entourage, including Brigadier General Truman Boudinot, commander of Combat Command B, and several ordnance specialists from 7th Corps headquarters. 2 M36 tank destroyers had been prepared for the demonstration, one loaded with standard 90mm armor-piercing ammunition, the other with Kowalski's modified rounds. The target was the burned-out hull of the first King Tiger that Kowalski's team had disabled the previous day, dragged into position at a measured distance of 1,800 yards. The observers took up positions where they could safely witness the firing. Demonstration. The first M36, using standard ammunition, fired 3 rounds at the King Tiger's frontal armor. Each impact produced a bright flash and a shower of sparks as the projectile shattered against the German armor. When the smoke cleared, inspection through binoculars revealed 3 impact marks on the armor, small dents and scorch marks, but no penetration. Then Kowalski's M36 took its position. The first round struck the King Tiger's frontal plate at almost the same spot as one of the previous impacts. The difference was immediately apparent. Instead of a flash and shower of fragments, there was a sharp crack and a small jet of flame as the tungsten penetrator punched through the armor, creating a hole approximately 2 inches in diameter. The second round, aimed at the lower glacis plate, produced similar results, clean penetration where standard ammunition had failed completely. Rose stood silent for a moment, processing the implications. For months, American armor had fought at a severe disadvantage against German heavy tanks. Tactical doctrine had been adjusted to compensate for this disadvantage, requiring complex maneuvers, numerical superiority, and close air support to overcome even small numbers of German heavy tanks. Now, suddenly, a staff sergeant with no formal engineering training had developed a modification that could neutralize this advantage, allowing American forces to engage King Tigers on equal or superior terms. He turned to Colonel Henderson and asked the question that would determine the course of the coming campaign. Can this modification be reproduced in quantity? Henderson nodded. Sergeant Kowalski believes so, sir. The basic concept is simple enough. The challenge is acquiring sufficient tungsten carbide and machining capacity. Rose didn't hesitate. Make it happen. I want a production plan on my desk by 0800 tomorrow. Priority authorization for any materials you need. This capability could change everything. Conversation that followed the demonstration lasted less than 15 minutes, but set in motion a manufacturing effort unprecedented in its improvisation and scale. Rose wanted these modified rounds distributed to every M36 tank destroyer battalion and every T-26 Pershing tank company before the main assault on the Siegfried Line. The offensive was scheduled to begin in 2 weeks. That meant 14 days to manufacture thousands of specialized armor-piercing rounds, distribute them to units scattered across a 100-mile front, and train crews in their use. It meant round-the-clock production. It meant mobilizing every ordnance unit, every maintenance company, every machine shop in the American sector. It meant improvising a mass production system for a device that had been invented less than a week earlier. Major William Garrett, 3rd Army Ordnance Officer, was given personal responsibility for the manufacturing program. A graduate of Carnegie Tech with a degree in metallurgical engineering, Garrett understood immediately that this was not a routine production job. This was an emergency crash program that might determine the outcome of the entire campaign into Germany. Garrett returned to his headquarters and within hours had issued orders that would set in motion one of the most rapid military production programs of the European campaign. Every ordnance company, maintenance battalion, and repair depot in the American sector received orders on September 17th to begin immediate production of what was now officially designated armor-piercing tungsten composite, 90mm, T-30E1. Though most soldiers simply called them Kowalski rounds. Specifications were transmitted by telephone and radio. Tungsten carbide penetrators, precisely machined to conical shape. Aluminum sabots designed to separate after leaving the gun barrel. Assembly procedures that required meticulous attention to detail. Simple enough that competent machinists could fabricate them with available equipment. Complex enough that it required skill and care to ensure the ammunition would perform reliably under combat conditions. The raw material presented the greatest challenge. Tungsten carbide was not abundant in the European theatre. It existed primarily in machine tools, drill bits, lathe tools, milling cutters, and other industrial equipment. Ordnance units began cannibalizing their own equipment, sacrificing long-term maintenance capabilities for immediate combat effectiveness. Requisition officers scoured supply depots, maintenance facilities, even captured German equipment for any source of the precious material. Additional supplies were airlifted from England, where industrial stocks were somewhat larger. The Air Transport Command diverted C-47 transports from their regular supply routes to deliver tungsten carbide tool bits, industrial cutting tools, and raw stock to ordnance units across the front. Within 3 days, a supply chain had been established, bringing material from as far away as Scotland to the impromptu production facilities near Aachen. The manufacturing work was intense and demanding. Machinists worked in shifts around the clock, transforming industrial cutting tools into precision armor-penetrating projectiles. The tungsten carbide had to be carefully shaped on specially adjusted grinding machines. It was too hard to be cut with normal machine tools. The aluminum sabots had to be precisely machined to ensure they would separate cleanly after leaving the gun barrel without disrupting the penetrator's flight path. Each round was essentially handcrafted, though production processes improved rapidly as experience accumulated. The first batches required nearly an hour per round. By the end of the first week, improved techniques and purpose-built jigs had reduced this to 20 minutes. Still slow by industrial standards, but fast enough to begin equipping frontline units with the new ammunition. Quality control was a constant concern. Each penetrator had to be perfectly balanced and aligned. Each sabot had to fit precisely around the penetrator and within the cartridge case. A misaligned round could damage the gun barrel or fly unpredictably after leaving the muzzle. Sergeant Kowalski himself travelled between production facilities, checking processes, suggesting improvements, demonstrating techniques he had developed during the prototyping phase. The first production rounds began reaching combat units on September 20th. Initially, each M36 tank destroyer received just 5 rounds, enough for emergency use against King Tigers, but not enough to change basic tactical approaches. Crews were briefed on the new ammunition's capabilities and limitations. They were told to use it only against the heaviest German tanks, preserving the scarce rounds for targets that could not be engaged effectively with standard ammunition. Reports from the first units to employ the Kowalski rounds in combat were overwhelmingly positive. A tank destroyer platoon near Stolberg engaged 2 Panthers at 1,500 yards, destroying both with single shots through their frontal armor. An M36 supporting the 1st Infantry Division reported penetrating a Tiger I at 1,800 yards, well beyond what doctrine considered possible. Most dramatically, 3 M36s from the 703rd Tank Destroyer Battalion engaged a group of 5 King Tigers near the Huertgen Forest, destroying all 5 German tanks while suffering no losses themselves. German reaction to the sudden improvement in American anti-tank capability was initially confusion. Field reports from German units mentioned new American weapons and special ammunition, but lacked specific details. German intelligence officers, trying to make sense of the reports, theorized that the Americans had deployed a completely new anti-tank system rather than a modification to existing weapons. This misconception actually worked to American advantage, as German commanders became reluctant to commit their heavy tanks without knowing exactly what they were facing. By September 25th, approximately 2,000 Kowalski rounds had been manufactured and distributed to tank destroyer battalions across the American sector. This represented enough ammunition to give each M36 an average of 15 specialized rounds, still not enough for unrestricted use, but sufficient to significantly impact tactical planning. Tank destroyer commanders, previously instructed to avoid direct engagement with King Tigers, now actively sought out Germany's heaviest armor, confident in their ability to destroy these threats at ranges where they were previously vulnerable. The psychological impact on American forces was profound. Tank and tank destroyer crews, who had watched comrades die in hopeless battles against superior German armor, suddenly found themselves able to fight on equal or better terms. The fear that had gripped American armored forces when facing King Tigers gave way to a new confidence, a belief that no German tank was invulnerable, no tactical situation hopeless. Lieutenant Frank Ramirez, whose tank destroyer had fired the first combat rounds using Kowalski's modification, expressed this transformation in a letter to his family dated September 28, 1944. Something has changed out here. A month ago, we were terrified every time we heard reports of tigers in the area. We knew our guns couldn't touch them unless we got suicidally close. Now we hunt them. Yesterday, we got one at a range where they thought they were completely safe. You should have seen their surprise when our round went straight through their front armor. This war isn't over, but for the first time, I believe we're going to win it sooner rather than later. The shift in tactical reality was accompanied by a shift in operational planning. Major General Rose, commanding the 3rd Armored Division, began developing plans for a major armored thrust toward Cologne once the Siegfried Line was breached. Previous planning had been cautious, assuming that German heavy armor would force American columns to advance slowly with extensive infantry and artillery support. The new anti-tank capability allowed for more aggressive planning, envisioning rapid armored exploitation that would prevent German forces from establishing new defensive lines east of the Rhine. By October 1st, production of Kowalski rounds had reached 500 per day across all manufacturing sites. This allowed for more generous distribution, with each tank destroyer now carrying 25 to 30 specialized rounds as standard loadout. The first Pershing tanks, armed with the same 90mm gun as the M36 but mounted in a fully traversing turret on a heavily armored chassis, began arriving in the European theatre in limited numbers. These tanks, already nearly equal to the King Tiger in protection and mobility, became decisively superior when equipped with Kowalski's specialized ammunition. October 2nd, 1944. The American offensive to breach the Siegfried Line began across a broad front. The main effort was conducted by 7 Corps, with the 1st Infantry Division and 3rd Armored Division leading the attack. German defenses were formidable concrete bunkers, extensive minefields, pre-registered artillery. But the most dangerous component of the defense was supposed to be the armored reserve, primarily Panzer Lehr Division with its complement of Panther and King Tiger tanks. When this reserve was committed on October 3rd to counter American penetrations near Aachen, it ran directly into prepared positions held by the 703rd and 704th Tank Destroyer Battalions. The resulting engagement, which German records would later call the Black Day, saw 17 German heavy tanks destroyed in less than 30 minutes, most at ranges exceeding 1,500 yards. American losses were limited to 2 M36s damaged by artillery fire rather than tank rounds. German commanders, unable to understand how American forces were suddenly able to penetrate the heaviest armor at extreme ranges, became paralyzed with indecision. Armored reserves that should have been committed to seal off penetrations were held back out of fear they would meet the same fate. This hesitation allowed American infantry to clear paths through the Siegfried Line's fixed defenses, creating gaps through which armored columns could advance. By October 5th, the 3rd Armored Division had broken completely through the Siegfried Line and was advancing toward the Ruhr River, the last significant natural obstacle before the Rhine. German attempts to establish new defensive positions were repeatedly disrupted by the speed of the American advance. For the first time since entering Germany, American forces were able to conduct the kind of mobile warfare they had practiced throughout the advance across France. Post-battle analysis conducted by American intelligence officers in the weeks following the Siegfried Line offensive revealed the decisive role of Kowalski's ammunition modification. Staff officers examined after-action reports, interviewed unit commanders, and compiled statistics on armored engagements during the offensive. The conclusion was clear and dramatic. American tank destroyers equipped with Kowalski rounds had destroyed approximately 80% of the German heavy tanks encountered during the offensive, most at ranges previously considered well beyond effective engagement distance. German prisoners, particularly tank crews and officers from armored units, expressed shock at the sudden change in American capabilities. A Panzer Lehr major, captured near Duren on October 8, told interrogators, "1 month ago, we could engage American tanks with complete confidence. Our King Tigers could destroy Shermans at 2,500 meters while remaining invulnerable to return fire. Then suddenly, without warning, American guns were penetrating our frontal armor at ranges we had believed impossible. It was as if the fundamental laws of ballistics had changed overnight. The strategic impact of the Siegfried Line breakthrough was immediate and far-reaching. By October 15th, American forces had reached the Ruhr River across a broad front. German attempts to establish a coherent defensive line had failed repeatedly. The Wehrmacht's armored reserves, which had been counted on to contain any American breakthrough, had been severely depleted by losses they could not replace. More importantly, German commanders had lost confidence in their heavy tanks, the very weapons that were supposed to compensate for Germany's increasing numerical disadvantage. For Andrew Kowalski, recognition came in the form of military awards and commendations, though with a peculiar mix of official acknowledgement and classified secrecy. General Rose personally recommended Kowalski for the Legion of Merit, a decoration typically reserved for officers who had distinguished themselves through exceptionally meritorious conduct in the performance of outstanding services. The citation accompanying the award praised Kowalski's contribution to the success of the Siegfried Line offensive and noted that his invention had saved countless American lives by neutralizing the threat of German heavy armor. However, the specific details of Kowalski's innovation were classified at the highest levels. Official reports referred only to improved ammunition performance and enhanced anti-armor capability. The actual mechanism, the tungsten carbide penetrator and aluminum sabot design, was considered sensitive technical information that might allow German engineers to develop countermeasures if captured. This classification created an unusual situation where Kowalski was simultaneously celebrated and obscured. His name appeared in unit citations and command reports, but the precise nature of his contribution remained restricted information. Some accounts described him simply as an ordnance specialist who had developed improved anti-tank tactics. Others mentioned technical modifications without specifying what they were. Kowalski himself, demonstrating the modesty that characterized many citizen soldiers, refused to take full credit for the invention. In debriefings with senior officers and later with technical intelligence teams, he repeatedly emphasized the collaborative nature of the development, crediting the Vermont lieutenant whose theoretical knowledge had sparked the initial idea, the machinists who had helped refine the design, and the tank destroyer crews who had risked their lives testing the unproven ammunition in combat. This attempt at sharing credit, though honorable, was largely overlooked in the official narrative. The Kowalski round entered military terminology, and Andrew Kowalski's name became known throughout the European theatre as the man who had solved the King Tiger problem. Yet the Vermont lieutenant, identified by historian David Robbins only as Maurice from Vermont, largely vanished from the historical record. Despite extensive research by military historians in the decades since, no primary source documentation has ever been found that verifies this man's full name, rank, or subsequent career. The entire account rests on Robbins' single mention in his book, possibly based on oral history that cannot be independently confirmed. In November 1944, the U.S. Army's Ordnance Department dispatched a team of engineers and metallurgists to the European theatre specifically to study Kowalski's ammunition design and formalize production specifications for implementation in stateside manufacturing facilities. The team, led by Colonel Thomas Mitchell from Aberdeen Proving Ground, spent 2 weeks working directly with Kowalski and the improvised production teams that had been manufacturing the specialized rounds since September. Mitchell's team was astonished by what they found. Working with limited resources, minimal equipment, and under combat conditions, Sergeant Kowalski had developed an ammunition design that matched or exceeded anything the Army's research facilities had produced. The tungsten carbide penetrator concept was not entirely new. Similar approaches had been explored in laboratory settings, but Kowalski's practical implementation, particularly the aluminum sabot design, represented a significant advance over existing prototypes. Colonel Mitchell's report, filed on November 20th, 1944, recommended immediate adoption of Kowalski's design as the standard armor-piercing round for all 90mm guns in U.S. service. The report specifically noted, Sergeant Kowalski's innovation, developed under combat conditions with improvised materials and equipment, demonstrates performance characteristics superior to anything currently in production. The urgency of the tactical situation demanded immediate implementation without normal testing protocols, but combat results have provided more compelling validation than any laboratory assessment could offer. By December 1944, factories in the United States had begun mass production of the T-30E16 armor-piercing round, based directly on Kowalski's design, but with industrial-grade materials and standardized manufacturing processes. The first shipments of factory-produced ammunition began arriving in the European theatre in January 1945, gradually replacing the handcrafted rounds that had been produced in the field. For Kowalski himself, the war took an unexpected turn in December 1944 during the Battle of the Bulge. The German offensive in the Ardennes caught American forces by surprise, creating a massive bulge in the Allied line. Units that had been preparing for offensive operations were suddenly thrown into desperate defensive battles as German armoured columns drove deep into Belgium. The 3rd Armoured Division, including Kowalski's tank destroyer battalion, was among the first units rushed to the threatened sector. On December 18th, near the town of Hotten, Kowalski's M36 was part of a task force, attempting to block a German armoured column led by Tiger II tanks of the 501st Heavy Panzer Battalion. In the ensuing engagement, Kowalski's tank destroyer destroyed 3 King Tigers at ranges between 1,200 and 1,800 yards, a remarkable achievement that helped blunt the German advance. But as the battle continued into the night, Kowalski's position was hit by German artillery fire. A 105mm shell exploded near his tank destroyer, sending shell fragments through the open turret. Kowalski was severely wounded by shrapnel in his chest and right arm. He was evacuated under fire by his crew, transported to a field hospital, then moved through the medical chain to rear area facilities in France and eventually England. Surgeons saved his life, but the wounds ended his combat service. The damage to his right arm, his dominant hand, was particularly severe, requiring multiple surgeries and leaving him with limited function. Andrew Kowalski's war was over. He had entered it as an ordinary steelworker from Pittsburgh and would leave it as the man who had changed the course of armoured warfare in Europe. Kowalski returned to the United States in February 1945 for continued recovery and rehabilitation at Walter Reed Hospital. There, he received a surprise visitor, General Dwight D. Eisenhower, Supreme Commander of Allied Forces in Europe, who was in Washington for high-level strategy meetings. Eisenhower had heard the story of the Pittsburgh steelworker, whose innovation had helped break the back of German armoured resistance, and wanted to personally thank the sergeant. The meeting, documented in Eisenhower's appointment diary but otherwise little publicized at the time, lasted approximately 20 minutes. According to witnesses, Eisenhower told Kowalski that his contribution to the war effort exemplified the best of American ingenuity and initiative. "You saw a problem that the best engineers in the army couldn't solve," Eisenhower reportedly said, "and you solved it with practical knowledge and common sense. That's the American way of war." Kowalski was discharged from the army in June 1945, 1 month after Germany's surrender. He returned to Pittsburgh with a partially disabled right arm, a collection of medals including the Legion of Merit, Bronze Star, and Purple Heart, and a recommendation from General Rose that would help him secure a position as a technical consultant with Carnegie Steel. The story of Andrew Kowalski and the specialized armor-piercing ammunition that changed the balance of power in armored warfare became part of military legend, though one less widely known to the general public than many other wartime innovations. Technical details of the ammunition remained classified until the early 1960s, limiting public discussion of exactly how American forces had suddenly gained the ability to destroy Germany's heaviest tanks at previously impossible ranges. Within military circles, however, the Kowalski round became a case study in battlefield innovation and the critical importance of practical problem-solving under combat conditions. The tungsten carbide penetrator concept that Kowalski pioneered would influence ammunition design for decades, eventually evolving into the modern depleted uranium penetrators used in current armor-piercing rounds. In 1952, the U.S. Army Ordnance Corps established the Kowalski Award for Technical Innovation, presented annually to an enlisted soldier who developed a significant field modification or technical improvement that enhanced combat effectiveness. The first recipient was a master sergeant who had modified radio equipment during the Korean War to function reliably in extreme cold weather conditions. Andrew Kowalski himself returned to the steel industry, working as a metallurgical consultant for Carnegie Steel and later U.S. Steel, until his retirement in 1975. He rarely spoke about his wartime experiences or his role in developing the ammunition that helped break German armored dominance. When asked about it by colleagues or at the occasional veterans' reunion, he would typically downplay his contribution, emphasizing instead the collaborative nature of the development and the courage of the tank destroyer crews who had implemented his innovation in combat. On January 15, 1962, 11 years before his death, Kowalski received a letter from former Lieutenant Frank Ramirez, who had commanded the tank destroyer that fired the first combat rounds using Kowalski's modified ammunition. Ramirez, by then a successful civil engineer in California, had maintained contact with several members of his former crew, but had lost track of Kowalski after the war. The letter, which Kowalski's family would preserve and later donate to the U.S. Army Ordnance Museum, expressed in simple terms the impact of one man's practical innovation. "I don't know if you realize how many lives you saved," Ramirez wrote. "Before your special rounds, we felt helpless against those German monsters. We would see them at a distance and know we had to either get suicidally close or watch them destroy our tanks one by one. After your rounds arrived, everything changed. We could fight back. We could win. I commanded a tank destroyer for 8 more months after that first engagement, all the way to the Elbe River. My crew and I survived the war. I came home, married my sweetheart, had 3 children. I've had 20 years I might never have had if you hadn't figured out how to punch through those Tiger tanks. I just wanted you to know that." The legacy of Andrew Kowalski's innovation extends far beyond the immediate tactical impact it had during the final months of World War II. In the decades following the war, his contribution became the subject of detailed study in military academies, technical schools, and professional military education courses worldwide. The Kowalski case is regularly taught as an example of battlefield innovation, organizational flexibility, and the decisive impact that individual initiative can have when supported by leaders who recognize and implement good ideas quickly. The story illustrates several lessons that remain relevant to military operations in the modern era. First, it demonstrates the critical importance of creating organizational cultures that encourage innovation at all levels of the command structure. Andrew Kowalski was a staff sergeant, an enlisted man with no formal engineering credentials. Yet his immediate superiors were willing to listen to his idea, provide resources for testing, and forward the successful demonstration to higher command. This willingness to take ideas seriously, regardless of their source, represented the American military at its best, flexible, pragmatic, and fundamentally democratic in its approach to problem-solving. Second, the story highlights the value of practical experience and industry-specific knowledge in military applications. Kowalski's background in steel manufacturing gave him insights into metallurgy and materials science that formerly trained military engineers might lack. He understood steel at a visceral level, how it behaved under stress, how different compositions and treatments affected performance, how it might fail when subjected to extreme impact. This knowledge, gained through years in Pittsburgh's steel mills, proved more valuable in solving the specific problem of King Tiger armor than theoretical ballistics training. The third and perhaps most important lesson centers on the speed of implementation. General Rose's decision to authorize immediate production of Kowalski's modified ammunition, mobilizing every available ordnance unit for round-the-clock manufacturing, transformed a single sergeant's improvisation into a theater-wide capability in less than 2 weeks. This rapid implementation was possible only because American military leadership valued results over bureaucratic process, and because American logistics and industrial capacity were flexible enough to support rapid adaptation. In a more rigid military system, Kowalski's innovation might have been evaluated by committees, tested extensively in controlled conditions, sent to factories in the United States for mass production, and finally issued to units months later, long after the critical moment had passed. The ability to compress this cycle from years or months to days represented a decisive advantage that German forces, despite their technical excellence, could not match. The ammunition concept itself has become a subject of extensive technical study as an example of how relatively simple innovations can produce outsized tactical effects. Prior to Kowalski's design, American anti-tank ammunition development had focused primarily on increasing muzzle velocity, making projectiles fly faster to increase their kinetic energy on impact. This approach had inherent limitations based on gun barrel strength, propellant chemistry, and other factors. Kowalski's insight was to focus instead on the penetrator itself, making it smaller but harder, concentrating the same kinetic energy on a much smaller impact area. The tungsten carbide material maintained its integrity on impact rather than deforming or shattering, allowing it to punch through armor that defeated larger but softer steel projectiles. This basic principle would influence ammunition design for decades, eventually leading to modern armor-piercing, fin-stabilized, discarding sabot, APFSDS rounds used in contemporary tank warfare. A technical report prepared by Aberdeen Proving Ground in 1946, declassified in the 1970 seconds, noted, Sergeant Kowalski's field expedient design anticipated the direction of formal anti-armor research by at least 5 years. Working with salvaged materials and improvised manufacturing techniques, he independently developed concepts that would later emerge from extensive laboratory research programs. That he did so under combat conditions, without access to test facilities or theoretical models, speaks to both his practical insight and the American tradition of field innovation. In the immediate post-war period, as tensions with the Soviet Union escalated into the Cold War, the lessons of Kowalski's innovation informed American military doctrine and planning. The new threat was Soviet armor, thousands of tanks that could potentially surge across Western Europe in a massive offensive. American planners, contemplating how to counter this threat with numerically inferior forces, drew directly on the experience of defeating German heavy tanks in 1944–45. The result was a doctrine that emphasized qualitative advantage over quantitative superiority. American tanks would not need to match Soviet numbers if they could destroy Soviet tanks at ranges where they themselves were invulnerable to return fire. This led to a focus on superior fire control systems, better optics, and advanced ammunition, all concepts that traced their lineage directly to the principles Kowalski had demonstrated with his improvised penetrators. Colonel William Clemens, who had served as First Army's chief ordnance officer during the Siegfried Line offensive, later became a key figure in post-war armor development programs. In a 1952 speech to the American Ordnance Association, he explicitly connected Kowalski's innovation to emerging Cold War doctrine. The lessons we learned in 1944 remain valid today. We faced a numerically superior enemy with qualitatively superior heavy tanks. A single sergeant with practical knowledge, and the initiative to apply it changed that equation overnight. As we face the prospect of thousands of Soviet tanks, we must remember that technical innovation, rapidly implemented, can overcome numerical disadvantage. Andrew Kowalski himself had a successful, if relatively quiet, post-war life. After his discharge from the Army in June 1945, he returned to Pittsburgh and accepted a position with Carnegie Steel as a metallurgical consultant. His military experience, combined with his pre-war background in steel production, made him particularly valuable as the industry converted back to civilian production while incorporating wartime technical advances. In 1947, he married Eleanor Nowak, the daughter of Polish immigrants who had grown up in the same Pittsburgh neighborhood. They had 3 children, 2 sons and a daughter. Both sons would later follow their father into the steel industry, though neither experienced the dramatic circumstances that had allowed Andrew to apply his knowledge in such a decisive way. Kowalski's work at Carnegie Steel, and later at U.S. Steel after the companies merged, focused primarily on developing improved high-strength steel alloys for industrial applications. Several of the metallurgical innovations he contributed to would later find applications in civilian infrastructure projects, bridges, skyscrapers, and eventually offshore oil platforms. While less dramatic than his wartime achievement, this work allowed him to continue applying his practical knowledge of steel to solve important technical challenges. Throughout his civilian career, Kowalski maintained a low profile regarding his wartime contributions. Unlike some veterans who built post-war identities around their military service, he rarely discussed his role in developing the ammunition that had changed the course of armored warfare in Europe. When pressed by colleagues or at occasional veterans' gatherings, he would typically deflect attention, emphasizing the collective effort rather than his individual contribution. This modesty was typical of many World War II veterans, particularly those from working-class backgrounds who viewed their service as a duty rather than an achievement. For Kowalski, the innovation that had earned him the Legion of Merit was simply what any skilled steelworker would have done in the same situation, applying practical knowledge to solve a pressing problem. In 1958, 13 years after the war ended, Kowalski received a letter from Germany that surprised and moved him deeply. The letter came from Hans Müller, who identified himself as a former King Tiger commander with the 503rd Heavy Panzer Battalion. Müller explained that he had survived the war and eventually returned to his pre-war profession as an engineer. Through professional journals and technical publications, he had learned about Kowalski's role in developing the ammunition that had so dramatically shifted the balance of armored warfare in late 1944. "I lost many comrades to your invention," Müller wrote. "At the time, we could not understand what had happened. Our tanks, which we had believed invincible, were suddenly being destroyed at ranges where no American gun should have been effective. It was as if the rules of physics had changed overnight. Now, years later, I understand that they did not change, you simply found a better way to apply them." Müller's letter continued with an observation that captured the paradox of technical innovation in warfare. "As soldiers, we fought against each other. As engineers, I believe we would have understood each other completely. Your solution was elegant in its simplicity, brilliant in its application of basic principles. In another world, we might have worked together rather than against each other." Kowalski responded to Müller's letter with equal grace, acknowledging the shared technical understanding that transcended the wartime enmity. This correspondence, which continued sporadically for several years, revealed how technical professionals on opposing sides could recognize and respect each other's innovations, even when those innovations had been deployed against them. In 1965, the U.S. Army Ordnance Corps formally inducted Andrew Kowalski into its Hall of Fame, recognizing his contribution to armored warfare and ammunition design. The ceremony, held at Aberdeen Proving Ground, brought Kowalski back into brief public attention. Several newspapers ran stories about the steel man who beat the King Tiger, though most accounts focused more on the dramatic narrative than the technical details of his innovation. At the induction ceremony, Major General William Eifler, Chief of Ordnance, summarized Kowalski's contribution. "In the long history of warfare, there have been moments when a single innovation changed the course of battle. Sergeant Kowalski's development of tungsten carbide penetrators for the 90mm gun represents such a moment. Working with limited resources under combat conditions, he applied practical knowledge to solve a problem that threatened the entire Allied advance into Germany. His achievement stands as a testament to American ingenuity and the decisive impact that individual initiative can have when supported by an organization that values results over credentials." As he aged, Kowalski became more willing to discuss his wartime experiences, particularly with his grandchildren who were naturally curious about their grandfather's medals and commendations. He would tell them stories about the war, but always emphasized the teamwork and collective effort rather than his individual role. He wanted them to understand that innovation rarely happens in isolation. It emerges from collaborative problem-solving and is implemented through organizational effort. To his eldest grandson, who showed an interest in engineering, Kowalski once explained his philosophy of problem-solving. "The answer is often simpler than you think. When we were trying to figure out how to defeat those German tanks, engineers were designing bigger guns, more powerful propellants, complicated new weapons. But sometimes the solution isn't a bigger hammer, it's a sharper nail. Look for the simplest approach that applies the basic principles correctly. That's usually the best solution. On October 17, 1983, Andrew Kowalski passed away at his home in Pittsburgh at the age of 70. The cause was a heart attack, unexpected, though he had been treated for hypertension in recent years. He was buried with military honors at Allegheny Cemetery in Pittsburgh, his casket draped with the American flag, a rifle volley fired over his grave by an honor guard from the local VFW post. Among the mourners were several veterans who had served with him in the 703rd Tank Destroyer Battalion, men whose lives had been directly impacted by his innovation. His obituary in the Pittsburgh Post-Gazette summarized his life with typical understatement. Andrew J. Kowalski, 70, retired metallurgical engineer, passed away Sunday at his home in Squirrel Hill. Mr. Kowalski worked for U.S. Steel for 30 years before his retirement in 1975. During World War II, he served with the 703rd Tank Destroyer Battalion and received the Legion of Merit for developing an improved anti-tank round that proved effective against German heavy tanks. He is survived by his wife Eleanor, 3 children, and 7 grandchildren. What the obituary couldn't capture was the ripple effect of Kowalski's innovation, how a single insight, born from practical experience and implemented through collective effort, had helped turn the tide of the Allied advance into Germany and potentially saved thousands of American lives. Nor could it convey how the principles he demonstrated would influence ammunition design and anti-armor doctrine for decades after the war. 5 years after Kowalski's death, in 1988, military historian David Glantz was conducting research for a book on comparative Soviet and American tank development during the Cold War. In the course of his investigation, he discovered a remarkable Soviet document from 1945, a technical assessment prepared by Soviet engineers who had examined captured German and American tanks and ammunition following the fall of Berlin. The document, which had remained classified in Soviet archives until the late 1982, contained a detailed analysis of the tungsten carbide penetrators used in American 90mm ammunition. The Soviet engineers had reverse-engineered samples found in captured American tanks and equipment depots, determining their composition and manufacturing techniques. What was striking about the document was its conclusion. The American tungsten carbide penetrator design represents the most significant advancement in anti-armor technology encountered during the Great Patriotic War. Its ability to defeat the frontal armor of the King Tiger tank at ranges exceeding 2,000 meters fundamentally alters the balance of armored warfare. Immediate priority should be given to developing similar capability for Soviet tanks and anti-tank guns. This Soviet assessment, written when the wartime alliance was already giving way to Cold War hostility, represented professional respect for technical innovation that transcended political boundaries. The Soviet engineers recognized the elegance and effectiveness of Kowalski's design, even as their government was positioning itself against the United States in the post-war order. The document had a final note, added in handwriting rather than typed with the main text. We must determine whether this was the product of American industrial research laboratories or a battlefield innovation. If the latter, we must understand how American military organization facilitates such rapid field development and implementation. This question, how the American military system could produce and rapidly implement a battlefield innovation that matched or exceeded anything coming from formal research programs, pointed to a strength that extended beyond technical capability. It highlighted the cultural and organizational factors that allowed good ideas to emerge from any level and be implemented quickly when they demonstrated value. In this sense, Andrew Kowalski's story represents not just an individual achievement, but a testament to a system that valued practical results over formal credentials, that could recognize and implement good ideas regardless of their source, and that could compress the cycle from concept to battlefield application when circumstances demanded urgency. The lessons of Kowalski's innovation continue to influence military thinking in the 21st century. Modern armor and anti-armor systems have evolved dramatically since World War II, incorporating technologies that would have seemed like science fiction to the soldiers who fought in Europe in 1944 to 45. Yet, the fundamental principles remain the balance between protection, firepower, and mobility that defines armored warfare, and the constant cycle of innovation as weapons and countermeasures evolve. Perhaps most importantly, Kowalski's story remains a powerful example of how individual initiative, practical knowledge, and organizational flexibility can combine to overcome seemingly insurmountable challenges. In an age of increasing technological complexity, when specialized knowledge is increasingly compartmentalized and formal credentials often determine who can contribute to problem solving, the story of a steelworker from Pittsburgh who changed the course of armored warfare offers an important counterpoint. It reminds us that practical experience and hands-on knowledge remain invaluable, that good ideas can come from anywhere within an organization, and that the ability to recognize and rapidly implement innovation can provide decisive advantage in any competitive environment, whether in warfare, industry, or any other field of human endeavor. Today, a small display in the U.S. Army Ordnance Museum at Fort Lee, Virginia, commemorates Kowalski's innovation. It contains one of the few surviving examples of the field-manufactured tungsten carbide penetrators, alongside a section of King Tiger armor plate showing the distinctive puncture created by such a round. A simple plaque describes the technical achievement and its impact on the campaign in Europe. But perhaps the most fitting memorial to Andrew Kowalski's contribution isn't found in any museum or history book. It exists in the organizational DNA of the American military, in the continuing emphasis on battlefield innovation, in the programs that encourage soldiers to develop and submit ideas for equipment modifications, in the cultural expectation that good ideas should be recognized and implemented regardless of their source. When a young specialist in Iraq developed an improvised armor solution to protect Humvees from roadside bombs, or when a sergeant in Afghanistan created a modified radio antenna that extended communication range in mountainous terrain, they were walking the same path that Andrew Kowalski blazed in 1944, applying practical knowledge to solve immediate problems, improving capability through individual initiative supported by organizational flexibility. The tungsten penetrators that Kowalski developed were eventually replaced by more advanced designs. The M36 tank destroyers and Sherman tanks they equipped were retired from service decades ago, but the principle he demonstrated that determined individuals with practical knowledge can solve problems that seem insurmountable to established experts remains as relevant today as it was when a staff sergeant from Pittsburgh changed the balance of armored warfare and helped open the road to Germany. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.